Just click this button right here. All right, we good to go. So before we start today, does anybody have any questions, any homework questions you guys want to go over, any topics that y'all don't understand? Anything? Nothing? All right. Let's jump into today's lesson. I mean, I'm saying you did better than you think. Go ahead. I'm gonna post it on Sunday. Yeah, yeah. Because there's to be honest with you, like I was just looking at the review sheet with someone, and we only covered like half of the stuff that's on it, you know? So like I have more stuff to cover between today, tomorrow, and next week. But by Tuesday, maybe Wednesday, but probably Tuesday, we'll be done with everything on the review sheet. And then you can study on Wednesday and then test on Thursday. Yeah. Yeah. Okay. Okay, that's fair. I got you. I'll post it tonight after I post the videos for this week. Yeah. I don't want to like bombard y'all because I know y'all have homework and stuff, so that's what I was thinking about. All right, so I forgot how to do this. How I do this? Go ahead. Okay, I'll accept that. You wanna find a perfect square that goes into this, right? So you said four. I'll go with that. So this would be like what, 32 maybe? Am I right about that? Okay. So then the square root of four is what? Okay. So this is 2 square root 32. But I could break down 32 further, right? By what? Another 4? Okay, square root 4. And this would be square root 9. Let me think. 8, right? Okay. Okay. This is still there, right? Okay. 2, right? So this becomes 2 times 2 times. All right, so square root 4 is square root 2, right? And then the square root of 4 we know again is 2, right? So this is just 2 times 2 times 2 square root 2. All right? And then what's 2 times 2 times 2? 8. Good. So final answer, 8 square root 2. Very good. Questions on this? So another way we could have done this, right? If you saw the largest perfect square that goes into it, which in this case was actually 64, this would have been square root 64 times square root 2. And then the final answer, the square root of 64, is just 8 and then square root 2. This is another way you could do it. But listen, both ways is 100% correct. Both ways will give you 100% on the question, right? So it's okay if you see a square root and you don't initially see what the largest perfect square is that goes into it, but you see a smaller one, no problem. You just have to know that you have to keep going until you can't go anymore. And that's it. Questions on this, anybody? No? Okay. If you're wondering, those of you with the TI 36X calculator, it does do this for you. Mhm. Not yours. Mhm. The black one. Yeah. Yours does, but not hers. You know, yeah. Because her calculator's not black. You know how black are. Oh wait, hold on. I didn't even check the score. I'm over here chatting with y'all. What's going on with the World Cup? Argentina won? Mother. Mm, all right. Right? That's probably the reason why they on fire. So let's see. Saturday we got a France England game, and Sunday we got a Spain Argentina game. Mm-mm-mm. Lord, I think Spain is gonna win it all. I don't know. I heard that because I wasn't following Spain all along, but I heard from someone that was actually following Spain that they didn't even get scored on, you know? Like when they were like first starting out, like nobody scored on them. And then you have Cape Verde that tied with them. That's a shock, you know? And then everybody done took my idea, right? So I'm thinking like, all right, after seeing Cape Verde, I'm gonna go there. I'm gonna go visit. Don't you know everybody else wants to go visit now? I'm like, y'all, eh. Oh, that's a real hard question. How I do this? I don't even remember. Mhm. It's on the formula sheet too, if you guys want to check it out. Okay. Very good. That's the first move, right? So instead of that big square root, we're gonna square root the numerator individually and then square root the denominator. And we can do this because both the numerator and denominator are under the same radical, right? So I could individually put the radical there. All right, what's next? How do I do that? Close, close, close. The next thing I would like to do, to be honest, I would like to simplify the numerator. I feel like that would make it a lot easier, right? So we know that square root of 32 can get broken down into what? Square root 16 times square root of what? Good. Over square root 5. Now help me out. What is the square root of 16 again? I forgot. 4, right? So this is 4 square root 2. That's a 4 over square root 5. Now, as you were saying, I have an issue because I have a square root of 5 in the denominator. How do I get rid of that square root? Not square it, multiply it, right? By the square root of 5. So you're multiplying it by itself, right? That's how you get rid of the square root of the denominator. But you got to be fair, right? What you do to the bottom, you got to do to the top, right? And then you just multiply straight across, right? That's how we multiply fractions straight across. Numerator by numerator, denominator by denominator. So 4 square root 2 times square root 5 is, don't overthink it. It's 4 square root 10. Very good. And then square root of 5 times square root of 5 is, what is it? Square root of 25, which is, there we go. And that's it. That's your final answer. All right. Not too bad, right? Well, just to clarify, in case anybody's watching the recording, this becomes square root of 4 square root 2 times 5 over square root 5 times 5, which becomes 4 square root 10 over square root 25, which then becomes 4 square root 10 over 5. All right. Questions on this? Good. If you're wondering, a calculator does this too. All right, let's go over another question. Ooh, this is a good question. Go ahead.
Um, still couldn't get it to cut conference. It just does that's. Well, you know, don't.
Oh, it doesn't? So look, here's what you do: second and then the square root, but not the top button, the one below it, right? And then do the fraction button. You see that right above the 7? Yeah. It's gonna be a decimal. Got you.
Okay.
Sure. Okay. Remind me after class, and then we'll do it real quick. It should take like 2 seconds. Yeah. All right. I have another blast from the past question. Quick recap. I want to factor this. How I do that? I'll give you a hint. The answer looks like this. There's something inside though. What's the answer? It's okay if you can't tell by looking like I can, right? You guys can use the AC method, right? It'll give you the same answer. Me, on the other hand, I'm going to use a shortcut. But tell me the answer first, and then we'll go through the shortcut. So remember, A times C, so that's 9 times 4. And then I want two numbers that multiply to give me uh 36. And when I add them together, it will give me a negative 12. What are they? Don't overthink it. It's as easy as it sounds. Right. And then you rewrite this as 9x squared minus 6x plus 4. Factor by grouping. And then what's the final answer? Tell me. What is it? No. Close though. Do the AC method. It'll give you the answer. And then I'll show you the shortcut. Well, not really show you the shortcut. You've seen the shortcut already. You'll see it again. So I hear you with the 3x plus 2. That's one of them. What's the other one? It is a 3x as well. What is it? No. Okay. Actually, the 3x plus 2 is not even right. Now that I think about it, it's not even right. But the 3x right here is right. All right, 3x minus 2, that's good. And what's the other one? Remember, it has to multiply to 4. So if this is 2, what's the other one going to be? And what's the sign going to be? Good. That's the answer. All right. So let's talk about the shortcut. How did I know that? So I had 9x squared minus 12x plus 4, right? Now you know that 9x squared, this is just what? 3x squared, right? Minus 2 times 3x, right? Times 2 plus 2 squared, right? All right, you probably wonder where did that even come from, right? You guys remember this formula right here? A minus b squared is equal to a squared minus 2ab plus b squared. Same thing, right? So this becomes what? 3x, right? Bring the minus sign over here, right? Same minus sign, and then 2 squared. That's it. Yeah. Right. It should be -6, -6. Yeah. Mhm. Mhm. So let's say we were doing the AC method real quick. 9x squared minus 12x plus 4. Just a quick recap, right? A times C is equal to 9 times 4, which is 36. And your B term is equal to -12. Two numbers that multiply to positive 36 but add up to -12. This is -6 and -6. That's positive 36. And -6 plus -6, that's -12, right? So you rewrite the equation that you have, but instead of the 12x, the -12x, you have 9x squared minus 6x minus 6x plus 4. Then factor by grouping, right? Draw a line down the middle, right? So we have our left-hand group, our right-hand group. On our left-hand group, what's the greatest common factor there? 3x, right? So remember, when I factor out a 3x, it's like I'm dividing by 3x. It's like I'm dividing by 3x, right? So 9x squared divided by 3x is what? 3x. Very good, right? -6x divided by 3x is what? -2, right? Now, remember the sign, right, of your leading coefficient is the sign of your factor. So what is the greatest common factor between -6x plus 4, right, on the right-hand side? -2. So remember, it's like I'm dividing by -2. So I'm dividing by -2, right? So -6x divided by -2 is 3x, right? And then +4 divided by -2 is -2. Perfect, right? And then we're going to do the greatest common factor one more time. They both of these terms have 3x minus 2 in common, right? So I'm going to factor that out, 3x minus 2. Remember that when you factor out a 3x minus 2, it's like you're dividing by 3x minus 2, right? It's like you're dividing by 3x minus 2, right? What's left over in front? 3x minus 2. And that's how you do the AC method to get this, right? You could finish this off by saying 3x minus 2 squared. Right? Just a quick recap. All right.
So the problem is because minus two.
I would accept either one. Yeah. Some people would tell you that no, it should be 3x minus 2 squared, but I would accept either one.
So,
Hmm.
oh,
Yeah. Yeah, either one of those answers I would accept. Sure, sure, sure. So this is the original question. This is the answer that we got. This is me using a shortcut, right? This one in the middle. So this is the formula, and then this is how I translated our question into the formula. And then that gives us the final answer. All right. And then this is the AC method down here.
which method is first?
Any method, doesn't matter. I would rather, because it's a short class and a short time, I would rather you master AC method than to master these shortcuts. You know, shortcuts they work for one situation only. The AC method works for all situations, right? So I'd rather you master one skill and knock out the whole test than to go into the test with like four partial skills, you know, if that makes sense.
Those,
Yeah.
all these method, these, yes, method.
It's not there. It's not there. Yeah, yeah. Yeah.
I have, yeah.
But next week, you might not even need the AC method. Stay tuned. All right. More fun things are coming. All right. So before we get into what we're doing today, let's just talk a little bit. Gotta build your vocabulary before I show you what we're doing today. It's very, very easy. All right. Some of you, not naming out names, were trying to do this on this exam that just passed, right? But you needed this lesson to really know how to do it. That's the thing. Right? So a quadratic equation is an equation of the form ax squared plus bx plus c is equal to 0, where a does not equal 0. Quadratic equations differ from linear equations by including a quadratic term with the variable raised to the second power of the form ax squared. We use different methods to solve quadratic equations than linear equations because just adding, subtracting, multiplying, and dividing terms will not isolate the variable. All right. We have seen that some quadratic equations can be solved by factoring. In this chapter, we will learn three other methods, right, to use in case a quadratic equation cannot be factored. Oh, baby. About to be nice, right? So, this first method that we're going to be talking about, we're going to solve quadratic equations of the form ax squared is equal to k, right? And this was on your last test, right? So using the square root property, right? We have already solved some quadratic equations by factoring. Let's review how we use factoring to solve the quadratic equation x squared is equal to 9. This is what I wanted you to do on the test. You have x squared is equal to 9. You subtract 9 from both sides. You make the equation equal to 0. So x squared minus 9 equals 0. Then you factor it, right? So you have x plus 3, x minus 3. Then you set each one of those individually using the zero product property equal to 0, and you solve for your answer. X equals 3, x equals negative 3. Key thing to look at here, right? How many answers did this come out with? How many answers did we get in the end? We got two answers, right? One positive, one negative, right? Those of you who are trying to do this on the test gave me one answer. Yeah, that's 50% credit right there. Yeah, but I understand what you were trying to do. You were trying to use the square root property, but you didn't know it yet. So let's go through it right now. Let's go through it right now. Huh?
That zero property,
The zero product property, yes.
like, just I'm just saying, like, looking at that and everything,
Uh-huh.
how do you go from using zero product property on one side, and they're both the same, x minus three equals zero, x minus three equals zero. But when you slope it, it's x minus three, and then x equals three, and x equals -3. But they're both the same. So how did
Yeah,
they-
but one is a plus, one is a minus, so it's two different
No,
ones.
that's not come on.
Hold on, let me see. One sec. Let me just copy this.
Like, right there.
Okay. Ooh, what a typo. Ain't that a yeah, that should be a plus. My fault. Yeah, that should be a plus. Yeah. You're right, you're right. My fault. What a typo. Thank you for clarifying. I appreciate that. Yeah, yeah. My fault, my fault. All right. So we can easily use factoring to find solutions to similar equations like x squared equals 16 or x squared equals 25, because 16 and 25 are perfect squares. In each case, we would get two solutions, x equals 4, x equals -4, or x equals 5 and x equals -5, right? But what happens when we have an equation like x squared is equal to 7, since 7 is not a perfect square, right? We cannot solve an equation like this by factoring. So what do? Previously, we learned that since 169 is the square of 13, we can also say that 13 is a square root of 169. Also, -13 squared equals 169 as well. So -13 is also a square root of 169. Therefore, both 13 and -13 are square roots of 169. So every positive number, this is the key thing that you needed for the exam. Every positive number has two square roots, one positive and one negative, right? So we earlier defined that the square root of a number in this way. If n squared is equal to m, then n is the square root of m. Since these equations are of the form x squared is equal to k, the square root definition tells us the solutions are the two square roots of k. This leads us to the square root property. That's where we're at right now. So what is the square root property? The square root property is if x squared is equal to k, then x is equal to the square root of k, or x is equal to the negative square root of k. Or you can put them together and say x is equal to plus or minus the square root of k. All right. Any one of these two answers I'll accept. So this is an answer, or this is an answer. All right. Give me one, give me both. I don't care. But this is what you circle in the end, right? Notice that the square root property gives two solutions to an equation of the form x squared is equal to k. The principal square root of k and its opposite. We could also write the solution as x is equal to plus or minus the square root of k. We read this as x equals positive or negative the square root of k. All right. Now we will solve the equation x squared equal to 9 again, this time using the square root property. Oh, baby, watch this. This was a secret sauce right here. Wait till y'all see it. Wait till y'all see it. So we have x squared is equal to 9, right? And then we know that x is going to be equal to plus or minus the square root of 9, which is plus or minus 3. So our answer is just x equals 3 or x equals -3. All right. So what happens when the constant is not a perfect square? Let's use the square root property to solve the equation x squared is equal to 7. All right. So watch what happens with this. I'm going to show y'all. So let me just make sure. Good, 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 good. All right. So x squared is equal to 7, right? Using the square root property, the answer will be x is equal to positive square root 7 and x is equal to negative square root 7. It's that simple. All right. Let's try it out. How to solve a quadratic equation of the form ax squared equals k using the square root property. That's fine. Good. All right. So check this out now, right? Before, I would just factor this and set that equal to 0 and blah, blah, blah. But watch what I'm going to do here, right? I want to isolate, right, the variable. So I'm going to add 50 over here. I'm doing the reverse now. I'm going to add 50 over here. But what I do to one side, I have to do to the other, right? So I have x squared is equal to 50, right? And then now I want to get rid of that square that's on the x. So what am I going to do? I'm going to square root it, right? To get rid of the square over here. But you know what I do to one side of the equation, I have to do to the other side of the equation. This next fact is very important. Remember this, right? Anytime I square root a number, I'm going to get two answers out. I'm going to get a plus or a minus, right? So plus or minus square root 50. And then you could just simplify square root 50. Largest perfect square that goes into 50, we know is 25. So this is just plus or minus square root 25 times square root 2. And the square root of 25, we know is just 5, right? So this is just plus or minus 5 square root 2, right? So you could give me this as an answer and I would accept it. Or you could give me x equals negative 5 square root 2 and x equals positive 5 square root 2. And you could box both of them. I don't care. Whatever is easier for you. If you just give me 5 square root 2 without that plus or minus, that's half wrong. There's two answers here, right? There's a positive answer and a negative answer. And that's it. Do you like this more than factoring? A little bit? Okay.
They both have their uses.
Mhm.
Different
Yeah.
situations.
But after next week, factoring is a choice, not an obligation. All right.
It's not fair to use.
This method, along with the other methods I'm going to show you, you don't have to factor. You can choose not to. All right. How do we feel about this? Is it clear? Do you understand? Would you like to see another one, or can we move on? What do you think? Move on? All right. Everybody said to move on. Before we move on, real quick, just to make me feel good, right? I'd like to give you guys some notes. Okay. So this is how to solve a quadratic equation using the square root property, all right? Step one, isolate the quadratic term and make its coefficient 1, right? Step two, use the square root property, right? That's like square root both sides, right? Step three, simplify the radical. And then step four, check your solution, right? You guys remember how to check your solution. Just plug it in for the x and see if it verifies and it works out. All right. Questions on this? Anybody? Okay. Oh, by the way, that's the lesson for today. So if y'all want to like knock out y'all homework in the meantime, go ahead. All right. So I just have more examples built off the same thing. So here's another question. I have 3z squared is equal to 108, right? So it says step one, isolate the quadratic term. It's already isolated for us, so 3z squared. And then it says, and make the coefficient 1. So I want to get rid of this 3 in front of the z squared. So how do I get rid of this 3 in front of the z squared? How do I get rid of the 3? Divided by 3, right? But you know what I do to one side of the equation, I have to do to the other side of the equation. So now I have what? Z squared is equal to, what's 108 divided by 3? 96? It is? 36. That sounds better. Right? But now, and then I want to square root this now, right? To get rid of that square on the z. But what I do to one side, I have to do to the other. So now what do I have? I have z is equal to plus or minus the square root of 36. And what's the square root of 36? 6, right? So this is z is equal to plus or minus 6. If you want to give me this as an answer, I'll take it. Or you could tell me z is equal to -6 and z is equal to +6. And then you could just give it to me like this. You don't need that plus sign in the bottom. I just got excited and wrote that. All right. Any questions on this? All right. Is it clear? Like, do you want to see another one or can I move on? Good. Move on. All right. I'm sorry? Oh, wait, hold on. Let me see. Wait, give me 1 second. Give me 1 second. Coming back. Yeah, this is the original question over here. Yeah. And then after that, this is the workout for the bottom. All right. So the square root property states that if x squared is equal to k, right? What will happen if k is less than 0? This will be the case in the next example, right? Oh, baby. So I have x squared plus 72 is equal to 0. Remember what I want to do? I want to isolate the quadratic term. So how do I get rid of the 72? What? Perfect, right? I'm going to subtract 72 from over here to get rid of it. But you know, I got to be fair, right? What I do to one side of the equation, I have to do to the other side of the equation, minus 72. So now what do I have? I have x squared is equal to -72. What should I do next? Square root it, right? To get rid of that square. But you know what I do to one side of the equation, I have to do to the other side of the equation, right? So bam. So what happens to this? I have x is equal to, always remember, plus or minus, right? What's this going to be? Square root -72. What's the largest perfect square that goes into square root 72? Well, negative square root 72. Not 18, 36. All right, somebody said it, right? So I'm going to break this up into -36 times square root of 2, right? Now, what is the square root of -36? 6 what? No, 6 is a letter 6i, right? So this is equal to plus or minus 6i square root 2, right? This is my answer, 6i, right? Or you could say x equals -6i square root 2, or you could say x equals +6i square root 2. Yeah, I'll take either one of these. I'll take either The two together or the one apart? What's I? I is an imaginary number, right? So when I have square root of negative 36, right? Like this, right? So this could get broken down into square root 36 times square root negative 1, because you have negative 1 times 36, right? The square root of 36 we know is 6, right? And previously we weren't able to do anything with a negative number, but now I'm teaching y'all the square root of negative 1 is I for imaginary numbers, all right? I is an imaginary number. It's the square root of negative 1, a complex number. If you ever decide to go into computer engineering, right? Electricity is modeled as J, right? But that J that they use for electricity is the same I that we use here. Okay? Not that you need to know all of that. If you're gonna stick with IT, then stick with IT. Go ahead.
The J stands for volts.
Nah, it's an imaginary number. It's the same square root of negative 1, but the J is actually the current that goes through the wire. Yeah. How do we feel about this? Do we need to see another one or can I move on? See another one? All right. So try that out. This is c squared plus 12 is equal to 0. C for Chris. We good? All right, let's try this out. So what should I do first? I have c squared plus 12 is equal to 0. What's my first step? Perfect. Good job. Subtract 12, right? Because I want to get c squared by itself. But what I do to one side of the equation, I have to do the other side, right? Subtract 12. So now I have c squared is equal to negative 12. What should I do after that? Right, I'm going to square root this to get rid of the square. What I do to one side, I have to do to the other. So now what do I have? I have c equals what? Close. So plus or minus square root negative 12, right? And then break down square root negative 12 for me. What's the largest perfect square that goes into negative 12? 4, right? So this is going to be square root negative 4 times square root 3, right? And then what is the square root of negative 4? 2i, right? This is going to be plus or minus 2i square root 3. And that's it, right? You could give me this answer, or you could give me c equals negative 2i square root 3 and c equals positive 2i square root 3. Whichever one is easier for you, right? And just for clarification, square root of negative 4 gets broken down into square root 4 times square root negative 1, and that's how you get the 2i. Right? Let's see. Yeah. Negative 1 is always I. I believe it's on the formula sheet, so you even got to memorize it. You know? You look at like complex numbers or something like that, square root of negative 1 equals I. Yeah. Warren, check out square root of negative 12. Does the calculator give you I?
And
Yeah, negative 12. I'm just curious. I don't know.
syntax error.
Mm.
I might have typed it.
Not minus 12, negative 12. Mm. No I?
Yeah,
Okay,
I think I gotta do something else, but
let me see.
yeah. I gotta put it on a different mode. I think it's like problem solving mode or something like this.
It did give you the I, but it didn't simplify it. Let me see.
I think I gotta change the mode on like it's either problems or something like that. I forgot that. I had the instruction.
Nah, you good. You good right now. I'm looking at the modes right now. Yeah, it's multiplying it out, but it did give you the I. So look, Warren, if you look at the end of it, it does give you the I over here. See it?
Yeah.
It's little, but it's there.
Well,
But it's not giving you the 2 square root 3. It's,
yeah, the complex number.
yeah.
I'll make it do it.
Yeah.
Like, and that's what I was saying. I'm gonna have to do, like, when I get back home.
Yeah.
Like, do all
Got you.
kinds of different.
Ways to
like,
do it. I
exactly,
got you. I
like,
got you. Or just learn my way.
but, well, I mean,
Yeah.
I
Yeah.
have no problems with doing it like that.
Yeah.
It's just that, my mind gets short circuited by
I got you.
words. When it's
I got
text,
you.
for some reason, there's a command. Turn
I
it
feel
to
you.
keys or something.
All right, let's look at this question. So I have 2 over 3 u squared plus 5 is equal to 17. Tell me what to do. What should I do first? Exactly. I'm going to subtract 5 from over here. What I do to one side, I have to do to the other, right? So now what do I have? I have 2 over 3 u squared is equal to 12. Good. All right. And what do I do after that? Don't overthink it. Hmm. Mhm. So let me ask you something. If this was a 7, what would you do? If instead of 2/3 it was 7, what would you do? Like, yeah, 7u squared equals 12. What would you do to the 7? No. If it was 7x equals 12, what would you do to the 7? Not subtract. You would divide it, right? By 7, right? Literally do the same thing in this question. Exactly. Now we're talking. Divide by 2/3. And watch what happens. It cancels out, right? But what you do to one side of the equation, you have to do to the other side of the equation, right? But it's okay. We good because we know how to do this, right? 12 is a whole number. So you know that that's what? It's going to be, I'm sorry, it's going to be 12 over 1 divided by 2 over 3. How do we divide fractions? Keep change flip, right? So this is going to be u squared is equal to 12 over 1 times, flip the bottom, 3 over 2. And how do we multiply fractions? Straight across, right? Now I have to do some tricky stuff because I'm not that good at math, right? 2 goes into 2 once and 2 goes into 12 how many times? 6 times, right? So now 6 times 3, what's that? That's what I'm talking about. So now I have u squared is equal to 18. What do I do next? Exactly. I'm going to square root this. But what I do to one side, I got to do to the other, right? So this becomes u is equal to plus or minus the square root of 18. Right, let's break this down. Right, so this is going to become what? Plus or minus square root 9 times square root 2, right? What's the square root of 9? Perfect, right? So now I have u is equal to plus or minus 3 square root 2. Or you can say u equals 3 square root 2, and u also equals negative 3 square root 2. Now you can box both of them in. Your choice. Questions on this? Anybody? If the 9 was negative, it would be 3i. Yeah. We good? Do we need to see another one or we can move on? Next? Oh, we got more stuff. It's like this though. This is the topic of the day kind of thing. Yeah. Huh? Yeah, you good, you good, you know. I'm recording it, so just watch the recording. Yeah. All right, so let's move on. This next question is kind of the same. We just got to remember our rules a little bit for this next question. All right, so I have 2x squared minus 8 is equal to 41. Let me write that out. 2x squared minus 8 is equal to 41. How I do this? Tell me.
Start by, the, I,
Isolate the variable. That's what I need to do. Yeah.
yes. But I think the other side.
The reverse. Right. So I'm gonna add 8 to negative 8 to get rid of it. Right. Oh, we gotta be fair. When I do the one side of the equation, I gotta do the other side of the equation, right? So now I have 2x squared is equal to 41 plus 48. I'm excuse me, 41 plus 8, I'm sorry, is equal to I think 49. What do I do after that? Go ahead. Huh? Not square root, before the square root. Divide, right? By what? Exactly, right? I want the coefficient of my quadratic term to be 1. So I'm going to divide by 2. But what I do to one side of the equation, I have to do to the other side of the equation, right? So now I have x squared is equal to 49 over 2. What do I do now? Now say it. What do I do now? Square root it, right? Because I want to get rid of this square on the x. But what I do to one side of the equation, I have to do to the other side of the equation. So now I have x is equal to plus or minus, right? The square root of 49 over the square root of 2. Help me out. What's the square root of 49? 7. Very good. So this is x is equal to plus or minus 7 over the square root of 2. Am I done? No, right? What's wrong with this? Uh-huh. Exactly. Right. And how do I get rid of it? Right? You're right. So how do I get rid of the denominator, the radical in the denominator?
Um, Square. You have to,
It starts with an M. Not divide, the other one. Multiply, right? You got to multiply it by itself, square root 2. But you got to be fair. What you do to the bottom, you got to do to the top. So now what do I have? I have plus or minus, just multiply straight across. This is going to be 7 square root 2 over square root 2 times square root 2 is very good. So that's it. I would accept this whole thing as my answer, or if you want, you could break it apart and say x is equal to 7 square root 2 over 2, and x is equal to negative 7 square root 2 over 2. And I'll take the two of these as an answer. Questions on this? Anybody? It's clear? We can move on? No, we can't move on? You want to see another one? No, you sure? All right. It's okay. The next question is just like this anyway. But before we jump into that, let me just talk about what we're doing now. This is on your homework also. So now we want to solve quadratic equations of the form a times x minus h squared is equal to k using the square root property. So we can use the square root property to solve an equation of the form a times x minus h squared equals k as well. Notice that the quadratic term x in the original form, ax squared equals k, is replaced with the term x minus h, right? So ax squared equals k now becomes a times x minus h squared equals k. The first step, like before, is to isolate the term that has the variable squared. In this case, a binomial is being squared. Once the binomial is isolated by dividing each side by the coefficient of a, then the square root property can be used on the x minus h squared term. Let's try this out. Watch me do this real quick. This is going to be really cool. Watch me do this. All right. So I got 4 times y minus 7 squared. Excuse me 1 second, I have a pop-up. Sorry about that. All right. 4 times y minus 7 squared is equal to 48, right? Now, not allegedly, but what I really want to do here is I want to solve for y, right? So I'm going to divide by 4 to isolate my quadratic term. But what I do to one side of the equation, I have to do to the other side of the equation, right? So now what do I have? I have y minus 7 squared, of course, is equal to, what's that, 12, right? Now let's get rid of that square. So I'm going to square root this. But you know what I do to one side of the equation, I have to do to the other side of the equation, right? So now what do I have? I have y minus 7 is equal to plus or minus the square root of 12. And we know that the square root of 12 is going to get broken down into square root 4 times square root 3. And the square root of 4 we know is 2, right? So this is y minus 7 is equal to plus or minus 2 square root 3. Now, to get y by itself, all you have to do is add the 7 to the other side. So what's my final answer? Y is equal to 7 plus or minus 2 square root 3. This is my answer. Or you can write it separately. You could say y is equal to 7 minus 2 square root 3, and y is equal to 7 plus 2 square root 3. And I'll take these two as an answer as well. Questions on this? Anybody? Yep, no problem. You want to see the words or just the question? It's good. All right.
Sorry.
Got you. So any questions on this one? All I'm doing here, I'm just solving for y. It might sound complicated, but I'm just solving for y. You know, the important thing to know, excuse me, the important thing to note, when I square root a number, I get two answers, a positive and a negative. And that's it. Also, the 7 and the 2 square root 3, those can't be combined because they're different terms and not like terms. So just stay separate. So do we feel like we understand? Can I move on or do you want to see another one? Mhm. All right. Excuse me. Sorry about that. I think the smoke outside is getting to me. So here's another question. Very similar to the one we just did, but in my opinion, a lot easier. So let's say I want to solve x minus 1 over 3 squared is equal to 5 over 9. Okay, so x minus 1/3 squared is equal to 5 over 9. So tell me what to do here. Mm-hmm.
Getting what I claim, but I'm stating X, so.
I don't want to solve for x, right?
So we have to isolate X, basically X, soon is, we have to, it's the square, so we have to square the other two.
We have to square root it, right? So we square root the square to get rid of it. But what we do to one side of the equation, we have to do to the other side of the equation. So now I have what? X minus 1 over 3 is equal to plus or minus square root 5 over square root 9. Somebody help me out. What was the square root of 9 again? I forgot. So plus or minus square root 5 over 3. So I have, let me just rewrite this. X minus 1 over 3 is equal to plus or minus square root 5 over 3. No, no radical in the denominator here, so I'm chilling. What do I do next? How do I get x by itself? Somebody tell me. Go ahead.
So we can have the, sorry, term is current, so that is negative. Add or keep up.
Very good. So I'm going to add a positive 1/3 to the negative 1/3 to get rid of it. But what I do to one side of the equation, I have to do the other side of the equation. I'm going to add 1/3 to the other side of the equation. So now look at what I have. X is equal to 1/3 plus or minus square root 5 over 3. I would accept this as an answer. If you wanted to write it a different way, you could have written x is equal to 1 plus or minus square root 5 over 3. This is another way I would have accepted the answer, right? Or you could have broken them up, right? With one positive, one negative in the middle, right? I feel like you guys get the gist of that already. Yeah, I would accept any one of these answers, your choice, right? They're under the same denominator, so I could put them as an addition or subtraction up top. Radical 5 and 1 are two different terms. They can't be combined, so they stay separate. Hmm? Questions? Make sense? We can move on? All right. All right, just give me two more examples and then we could call it a day. All right. So I have this example here. Not too complicated, right? So this is 2 times x minus 2 squared plus 3 is equal to 57. Tell me what to do here. Perfect. I'm going to subtract 3 first from here, but what I do to one side of the equation, I have to do to the other side of the equation. So I have 2 times x minus 2 squared is equal to, what's that, like 54, something like that? All right. Now what do I do after that? Perfect, right? So I'm going to divide this side by 2. But what I do to one side of the equation, I do the other side of the equation, right? So this is going to be what? X minus 2 squared is equal to, what's that? 27. Perfect. Now, what do I do after this? I'm going to square root this side to get rid of the square. But what I do to one side, I got to do to the other. So now I have what? X minus 2 equals what? Square root what? 27. Good. Let's break down that square root 27. What is that? So square root 9, square root 3. And what's the square root of 9 again? Perfect. So x minus 2 equals plus or minus 3 square root 3. What do I do next? Exactly, right? What you do to one side, you do to the other. So now what do we have? X equals 2 plus or minus 3 square root 3. And that's it. Questions on this, anybody? It's clear? Could move on? All right, last example. Last example. Homework for this is already posted, so if you want to do that, you can. So walk me through how to do this. So I have 2x minus 3 squared is equal to negative 12. What should I do? Mhm. Square root it. Good. To get rid of the square, what I do to one side, I got to do to the other. So now what do I have? Tell me. So I have 2x minus 3 equals what? And what goes in front of that? In front of the answer, plus or minus, right? So plus or minus square roots, negative 4, square root 3, right? That's what you're saying. What's the square root of negative 4? Tell me. 2 what? 2i square root 3. Very good, right? And what do I do after this? Right, plus 3, right? And what I do to one side of the equation, I have to do to the other side of the equation, right? So now what do I have? I have 2x is equal to 3 plus or minus 2i square root 3. And what do I do after that? Perfect. And what you do to one side, you do to the other, right? So now what do we have? We have x is equal to, you could leave it as 3 plus or minus 2i square root 3 over 2. I would accept that as an answer. If you wanted to break it apart, you could. You could say x equals 3 over 2 plus or minus I square root 3. I would accept this as an answer as well, right? However you want to do it. Or if you want to break it up even further and have one of them as, a minus and one of them as a plus individually, and then circle the two of those, your choice. Okay. Questions on this? Anybody? You want to see another one, or y'all want to go home? What y'all want to do? Go home? All right. Come sign out. And that's it. Can I take this down? It's okay. I need time to start the download. You know what that'd be. All right.